Now we want to start working with arrays. We want to utilize the information that we've stored in them. And one of the ways we can do that is with a for each loop. A for each loop is like a for next loop. However, it deals specifically with arrays and collections and things of that nature. So here we have an example of a static two-dimensional array with the dimensions 2 rows and 4 columns. Now the purpose of this code is to load the array and then extract the data to print. To do this, we use a for each loop. But what I want you to notice is that when we load our array, notice how I have the numbers going in ascending order from left to right. So here we have 1, 2, 3, 4, 5, 6, 7, 8. Now, whenever I actually print these out using the for each loop, when they print out, it actually goes 1, 5, 2, 6, and so on. It goes in this order, it goes in ascending to descending order. So it goes 1, 5, 2, 6, 3, 7. The reason why they print out that way is that the individual elements in the array are listed in the order in which they were cycled through by the for each loop. Now, the thing to keep in mind about the for each loop is that it's always going to go through the innermost dimensions first, followed by the outer dimensions. So let's go ahead and show an example of this. Okay, in this example, we're going to review the for each loop. So what we're looking at here is a two-dimensional array. And we're going to think of this array as a collection of rows and columns. Specifically, this array is going to have 2 rows and 4 columns. This is also going to be a static array. So if you look down here where I have my code, I've done the best I can to make the code reflect the dimensions of our array. So I have 2 rows with 4 columns. Now I'm working along the convention that my values for each element will increase as I move from left to right along the columns and as I move down along the rows. So as you can see, going from left to right, I have 1, 2, 3, 4. Next row, 5, 6, 7, and 8. So the purpose of this exercise is for us to create this two-dimensional array, to load the array with this convention, this left to right convention, and then see how it prints out whenever we actually put it in a for each loop. So what's going to happen in this loop is that it's going to go through each element of the array and it's going to print it out. And the idea is we want to see how it prints out. So let's go ahead and cycle through this. So here I am loading my static array, and now I'm actually going to start printing it out. So it's going to start with each element. So we have 1. Now if you notice, it's not printing out in ascending order. It's printing out in a completely different order. So the loop has printed out the individual elements of the array in the order that they were cycled through by the for each loop. What's important to note is that the for each loop cycles through the innermost dimensions first, then it follows the outer dimensions. So if you notice here, we have 1, 2 for column 1. So the inner dimension is 1, 2, and then it goes to column 2. So it cycles through 1, 2 for column 1, then it goes to 1, 2 for column 2, 1, 2 for 3, and 3. So if I really want this to work, I need to make it so that my values go in ascending order based on the innermost dimension. And I'm going to change up the code. So I want you to notice right now I have my values assigned left to right. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to pause the video and I'm going to change my values around. Okay, so I've gone ahead and changed my values where I've assigned my values in the array. If you notice, now I have value 1, 2, 3, 4, 5, 6, 7, 8. So going along the innermost dimensions first, and then slowly increasing as I go to the outer dimensions of the array. So here we have an error listing, or a listing that is not correct. So let's go ahead and try it again. I'm going to clear this out, and I'm going to run through the code again. Again, we're going to assign our values. Now let's see how it prints out. So it's going through and it's printing the elements starting from the innermost dimension, working its way outward. So when you're working with an array and you want to work with the individual elements using a for each loop, you have to keep in mind that it's going to work with the elements starting with the innermost dimension and slowly working its way out. In this example, we're going to review the for each loop again, only this time we're going to work with a single dimensional dynamic array. What I want you to notice first is here where I declare my array. As you can see, I have my array declared as size 10. The thing to keep in mind is that the lower boundary of this array is actually 0 and the upper boundary is 10. But since we're starting at 0, that means that we have 11 elements within this array. If you look over here at the spreadsheet, you'll see where I have that reflected. You can see where I start up at 0 and I go up to 10. And if you count the number of elements, it's actually 11. If I want to specify a different lower boundary, I have to make a different type of declaration. So if you look just above it, I have an array declared a size 1 to 10. So this actually has a lower boundary of 1 and an upper boundary of 10. That means there's going to be 10 actual elements, not 11. So going back to our original declaration, I'm going to go ahead and run our code, and I'm going to stop whenever we decide to load the dynamic array, which is going to be right down here. So here I have n equals 0 because that is my lower boundary, and here my upper boundary is 10 because remember we have that assumed lower boundary of 0. Here I have I equals 1, and for array element 0, I is going to equal 1. For the next element, it's going to go up by an increment of 1. So let's go ahead and step through that. Okay, now I'm at element 1, and the value is 2. Element 2, and the value is 3. So I'm going to go ahead and fill up the array, and we're going to stop here where we go to print it out. So this is actually r equals 12 or row 12. As you can see here on the spreadsheet, that's the row that I'm starting on. So that's all that means is where I'm printing my variables at. So as I step through, now this time I'm working with a for each loop for this array. Because it's a single dimensional array, it's going to print the values in the order that they were loaded in. So if we look over here, we can watch the values as they're printed out. As you can see, we have 11 elements, even though the size of our array is from 0 to 10. So we, again, just emphasize the point that there is an assumed value for the lower boundary for this array of 0. So now I'm going to do the same thing, only I'm going to use the declaration of our array with 1 to 10 to see how that prints out. I'm going to change our worksheet over here to reflect that as well. Okay, so we look at our declaration for our array, and if you notice, it has a lower boundary of 1 and an upper boundary of 10. We can see that over here. I'm going to do the same thing as before, load the dynamic array exactly the same way, and print it out the same way. So I've loaded the array, and now let's see what happens whenever I print it out. Because we have only 10 elements, we only have value for 1 through 10 listed. Another way to get the same result is to use what's called option base at the top of your module. And this is a compiler note. So what I'm going to do is I'm going to go back to our original declaration of an array where we have an assumed value of 0 for the lower boundary and an upper boundary of 10. And that's where we came out with 11 elements. Only this time I'm going to go to the very top of the module and I'm going to type option base 1. So here I am at the top of the module, and I'm going to type option, base, and I have a choice. I can either have base 0 or base 1. That is going to be the assumed lower boundary for an array whenever we declare it. In this case, I'm going to do 1. I'm going to go back to my procedure, and I'm going to run through the code again. I have the same declaration of my array, which is 10, only this time there should only be 10 elements within it because we're starting at a lower boundary of 1. So here, if I look at my lower boundary, it starts at 1, and my upper boundary is 10. I'll run through the code again. If we look over here at the sheet, I end up with values 1 through 10 because there are only 10 elements in this array. Now keep in mind that the option base of 0 or 1 is strictly whenever we declare our variables in a manner where we don't list a specified lower boundary, such as here where we have declared array size 10. And it has to make a choice. Is it going to start at 0 or is it going to start at 1? This is not going to affect our lower boundary. So for instance, if I change things up again. Now in this case, what I'm going to do is I'm going to go here and I'm actually going to start our lower boundary, which I'm assigning a value to. I'm specifying it. I'm going to start it at 3. And let's see what happens whenever I do that. Let's look over here and see what the outcome is. Notice that it stops 3 elements short of the final. So as you can see, what's missing here are elements 2 and 1. So that's why we only have 8 elements. And again, because this is a single dimensional array, our for each loop is going to list the items or the elements in the order in which they were loaded.